camera.
It's
What? You add something to the end of the problem. When you have a vertical translation, you are adding something onto the problem. You know how when you have f of x minus 1, what does that do? Drops you down 1. That's a vertical translation. So we have this problem, and we have to write it with a vertical translation. Now, let's talk about what does it have right now? What does that problem have right now? It does not have a vertical dilation, it has a horizontal dilation. That's exactly right, by a factor of 1/5. So this has a horizontal dilation, and we want to rewrite it with a vertical translation. So remember that log 5x is the same as log 5 plus log x. Is log 5 a number? Do I have a vertical translation? Yeah. It's the log x curve moved up, whatever amount that is right there. All right, what else? What else? Anybody else have a question from quiz, review, or homework? Christopher?
2.12, number 5.
Homework again?
Yeah.
Okay. This is just exactly what you did on your quiz. You want to write this as a vertical dilation, which means you need to multiply it by something. That's what a vertical dilation is. So we know, Christopher, this can always be rewritten as log x over log 8. That is the change of base formula. It is a fundamental thing you need to know. That's the change of base. Now, I have rewritten this, but what base do I have up here, right here? 10. And that isn't what my problem asked. My problem said I need base 6. The change of base formula works with every base in the whole wide world. So, I'm going to make those 6s. Now I got it, because I am multiplying log base 6 of x by 1 over log base 6 of 8. And what does it mean to be a vertical dilation? It means you are multiplying by something. And this is what I'm multiplying by. Right? Yep. So easy. All right, who else? Sarah?
Can you do the, hold on, number 3 on the mini quiz?
Number 3 on the mini quiz. So what I would suggest you do on this problem is figure out what it looks like first, because I think it's going to make answering the questions a lot easier. And you all have your own style of doing things, but I always start with, what does a normal logarithm look like? This is a logarithm equation. A normal logarithm has an asymptote at 0, an intersect at 1, and looks like that. That is a normal logarithm, right? Now, what does that do to it? That is the same as, that's a reflection across the x-axis. That's what that does. If your base is less than 1, it takes that picture and turns it into this picture. That's what this does, right? Now, what does that do? Flips it back over, so now I'm back to my original in terms of shape. Okay? Now, what does that do? Shifts it left 7. So now the asymptote that was at 0 is now at -7. And the intercept, which was at 1, is now at -6. There's my picture. Back to the normal shape, shifted 7 units to the left. So, is this guy increasing or decreasing? Increasing. Concave up or down? Down. Asymptote? X equals -7. Let's get in the habit of including the letters. Asymptotes are lines, so our answer should be an equation. X equals -7. X-intercept is? Yep. Domain, what's my domain? What are my X's? -7 to infinity. And what are my range? My Y's? -infinity to infinity. Okay, Sarah? Got it? All right. Morgan?
Could you do on the mini quiz 4 each?
You need to simplify or evaluate 3 ln e squared. Okay? There are certain fundamentals that you learned last year and you just gotta remember them, okay? There is a property of logarithms that says the log base b of b to the nth is n, not 1. The log base b of b to the first is 1, but the log base b of b to the nth is n. Period. Always. So, a number in front is an exponent. So this is really ln e to the 6th. And ln is log base e. So what's log base e of e to the 6th? 6. Not e to the 6th, it's 6. The log base b of b to the nth is n. Okay? Morgan? All right, what else? Homework, quiz, review sheet.
You do. Number 1B on the quiz.
1B. This is, gotta put these logarithms together. Oh wait, before I can put them together, I need to deal with that 2. So that 2 is an exponent. So that second term is really log base 4 of 9 because it's 3 squared. Now I can put them together. X over 9. And then, since we're both log base 4s, I'll just solve x over 9 equals x plus 7. So times in by 9. And solving, I got -63 eighths.
Do you mark it?
I'm not done. In every logarithm problem, yeah, you gotta remember the domain. And in this problem, x has to be bigger than 0 and bigger than -7. So if I graph my number line, that's in green, that's in red, and this is a pink dot. Is the pink dot gonna be in the green and the red? No. Therefore, the pink dot cannot be the answer, and this problem has no solution. Okay? You must just somehow program your brain that when you see any problem involving a logarithm, you immediately think about restrictions on that domain. Because logarithms have them. Look at our graph, they have them. You've got to think about that when you're solving or graphing or anything. All right, what else? Sarah?
Can you do number 2 on the same page?
Number 2 on the quiz. All right, so I am finding an inverse. inverses of lots of things, and it doesn't matter what you're finding the inverse of. Exponent, logarithm, rational function, sine, cosine, it doesn't matter. If you're finding the inverse, what's the first thing you have to do? Switch your variables. So this is y. So when I switch, I have x equals negative 2 log 6 y plus 4 minus 2. Okay, now what? Add 2. We gotta solve for y, so we gotta get rid of that 2. And then we'll divide by negative 2. And you can do that individually, like this, or you can do it as one part. X plus 2 over negative 2. It doesn't matter one bit which way you do it. Now we have a dilemma, because there really isn't anything else we can do, like adding and multiplying and stuff. So we've got to get rid of this logarithm. So, as Morgan says, we'll unlog it. I prefer to think of that as log rolling, but it's up to you however you do it. We're going to log roll that thing. And then subtract 4 and write it in proper inverse notation. So the inverse is 6 to the negative 1/2 x minus 1 minus 4. Okay? All right. What else do we have? From homework, review sheet. Pretty much done the whole there. What else? Okay, good. Girls and boys. I passed this exam last night. I took it. I don't need to review. We're doing this for, who are we doing this for? That's right. So we're either gonna do it or we're not. I'm ready to move on. I'm itching to get back into the curriculum. So if you wanna review, then you better be ready to review. Alright? And quit the crap. Alright, so somebody give me a problem to do because you're making me cranky. Ella?
Homework 2.12, number 6.
Homework. Homework, oh, here it is, 212, number 6. Convert this into a natural, I already did this, probably one just like it. Basically, what are you being asked to do? Change the base from base 10, it's currently base 10. Change the base from base 10 into base E. The change of base formula says this is the log of x over the log of 10. What base do I want? I want base E. So ln x over ln 10. That now is written as a natural logarithm. Now, with a calculator, you can actually calculate that number. That's a number. But that's the setup right there. Chris?
2.122C.
We're just splitting up this expression into multiple logarithms. So just basically starting, I'm going to have ln 5 minus ln 3 minus ln e to the 17th. There's 3 parts to that problem. These are both being divided, so they're going to be subtracted. And then, what is log base e of e to the 17th? What is that? That's just 17. So So that would be your answer. With a calculator, you actually type on the thing, that's your answer. Okay?
On the review, could we do 1.6? Just like 1 or 2, just going over the end behaviors.
1.6, number 1. When we have a polynomial, and in 1.6, number 1, that's what we have. We have a polynomial. It's certainly not a logarithm or an exponent or anything like that. It's a polynomial. And in polynomial land, the term with the biggest degree, that is the highest exponent, has all the power. That's where the power is in the problem. We don't really care about any of the rest of that stuff. This is what we have to look at. So I noticed two things about it. First of all, it's odd. 5 is odd. And second of all, there's a negative out in front. So, gotta stop and think. Well, how do odd degree polynomials behave? They look like this. That's how they behave. They start down, end up. But, because of the negative, he's flipped, so he looks like this. Now, I don't know what's happening in the middle, I don't care, it's the ends that I care about. And I know that an odd degree polynomial has opposite in behavior, one's up, one's down. And in this case, because of the negative, I'm starting up and ending down. So, the limit as x approaches negative infinity, this would be my left, of k of x, is actually positive infinity. And the limit as x approaches infinity is negative infinity. Sarah?
Kind of similarly, can we do 1.7?
Okay, hang on to that, it's time for lunch, so I gotta let everybody go. We'll be back at 45. Back at 45 in your seats, ready to ask some questions. 45, in your seat, ready to ask questions.
Can we pause that?
Yeah, go ahead, just turn it off.